As you've learned the theory of this chapter, right? What is magnet? It has two poles, north and south. Unlike pole, attract, like pole, repel. But today I want to show you practically, is it true or wrong? Okay, so we have magnets, we have some other device that we are using. So I am going to introduce all the device that we are using for this experiment. So in the last class we have also learned that how passing current through a wire can produce magnetic field, right? And we have seen what to say, a magnet is moving when pass current through a wire. So which we are going to do practically today. So what we have seen, if we take a circuit and when we pass a current through it and we take a compass near to it, you can see there is a deflection. And today I bought for you, this is a compass. This is a compass. It will always direct toward north and south. Understood? This is called compass. And it has a small magnet inside it and it always inclined toward north and south. Wherever you keep, it will always let me keep this one in the look, this side is north and this side is south. So it is always pointing toward north and south. Wherever you move it, doesn't matter. It will always, this red will come always this side because this is north direction. Understood? And here we have magnet. आप लोग खेला होगा छोटा टाइम में like that, is not it? तो खेला होगा कि when you take magnet north south attract, when you take south north repel, simple thing. Clear this one? Okay, good. Now I told you that there is a field line. When there is a magnet, it is north pole and south pole. There is a field line originating from north pole and goes to south pole. Right? North pole to south pole. But inside the magnet it goes from south to north. It is called bar magnet. The strength is not so much because it has been like 4 to 5 years. It does not have so much power now. Okay, then also I will be showing the experiment. Today I will be showing you the magnetic field. The magnetic field is still there, but it is invisible. But we like to see it, right? Let us see it. Yes, let us see. For this, we need a paper. I have taken a paper. And this is the bar magnet, and I am placing above it. For this, we will be using some of the grains of iron. You can see, we have taken some iron grains, and we are going to sprinkle over the page, and you can see the pattern forms. Can you see, guys? Yes. So you can see, guys, there's so many field lines are there. It is arranging this way. It is making a loop, closed loop, because the strength of the magnet is not so much, so we cannot see the complete closed loop. But if the strength is so much, so we can see a loop that it is coming from north and is going to south. It's going to north and south. Clear? There is two poles. So it is a practical through which we can see the poles, or we can see the field line, which we cannot experience when it is outside, but when you take some iron grains you can experience. So they are in field lines. This is called field lines, which we have done through the help of magnet. Clear, son? So we have seen the field line. So let us keep it aside. Now let us come to the another experiment. Very interesting experiment. Last class I told you that when we pass current through a circuit, the compass deflects, right? Let us see. Let us see this thing. We have taken a compass here. Can you see any deflection now? No, we have not seen any deflection. But as we take the compass or the magnet toward it, you can see some deflection, right? You can see some deflection. You can see some deflection. When it took toward it, it will show some deflection and it take away again deflection. Clear?
Yes, sir.
Okay. Same deflection we can create when you pass current through it. Now guys, see. Now see, with a magnet there is a deflection. Okay. Now what we are going to do that we are taking a battery eliminator. It is called battery eliminator because if you use same battery, but this battery is only converting the AC current to DC current. What is the features? What is the advantage of this battery eliminator? Okay, we get a constant source of energy through this, right? And we can set to different volt. 2 volt you need, 3 volt you need, 4 volts, 5 volt, 8 volt, 10 volt. We can set according to our requirement, right? But if you use the pencil battery, what happens? The power gets finished very soon. While we are doing the experiment, it gets finished, so we cannot show it. So battery eliminator is very helpful for us. Now, what I am going to do is that I have taken a wire and I have made a coil, and this is called solenoid. The same coil that we use in the fan. It is called insulated copper wire. What is this wire called? Insulated copper wire. And this wire is used in making this fan, transformer, inverter. It is there. What is the meaning of insulation? Insulation means there is a copper wire inside it. There is a copper wire inside it. Above it, they have done a lamination of plastic or wax. There is a layer. There is another layer. Understood or not? When you just scratch it, if you have blade, do you have blade anyone? Blade, any kind of thing, sharp object. I could have shown you. Nothing. Cutter, blade, कुछ भी चीज, sharp चीज. Don't have. कोई नहीं लाते हैं. देखो बैग में चाकू को कुछ होगा. कुछ भी नहीं है. हाँ? ब्लेड है? हाँ तो बहुत जरूरी है. So, okay, whatever be. Now, if I scratch it now, so you can see when I scratch this, there is another wire coming out. Have you seen? So, when you scratch it, you see the main wire is coming out. Understood? Understood or not? If you connect the wire like that, the current will not pass. If the current is passing, if you touch also, then also you will not experience any electric shock. Because there is a layer upon it, layer of plastic or wax. Clear? But when I scratch it, you can see the main copper wire is coming out, through which the current can pass through. Clear? What is the meaning of insulation?
Yes.
Okay, very good. Now hold it. Now you can see, I will connect this battery or battery eliminator with this solenoid. Let's look here. Give the magnet. Hold that one. Now look. What is this called?
Safety pin.
Safety pin. How it is made up of? Irons. Made of irons. So when you take this magnet near to it, what will happen? Yeah, magnet can attract this iron. You have played, I think, right? When you were very small. But same effect we can produce by passing current. By passing current through this coil or through this wire, you can say. Okay? Same effect. Why it is attracted? Because magnet has this property. Magnet can attract the iron-like particles. I already told you all know very well, right? So okay, fine. Hold it. Fine. Now I am just placing this this pin, iron pins near to it, and I will pass current through it. And see, let us see. You can see when I pass current through it, it is attracted. So when I turn off the switch, it is losing its magnetic property. Again, if I turn it on, it becomes magnet, right? As soon as I pass the current, it behaves like a magnet, right? Again, when I switch off, it is switching off. Same experiment done by the scientist. So when he was passing the current through a circuit, he saw a deflection in the needle. Now you can see the different deflection. So this is the compass. Now you can see that the red needle is toward me, right? Now I will pass the current. Let us move let us move this all the pin from here. Now let us pass the current. Oh, understood? Understood or not? Yes. So when I pass the current, the needle moves. The needle show a deflection. The question is why? Why the needle is showing the deflection? Because when I pass the current through the coil or through the wire, there is a magnetic field produced around it, and due to this magnetic field, there is an impact upon this compass. Understand or not? As we have did the theory class yesterday, same thing. If you take no problem, you can see the deflection of this here also, and you can see the attraction also. Deflection and attraction. Movement. Okay. So what we have seen, when we pass the current through a circuit, there is a magnetic field produced around it, and this magnetic field show an impact on the compass, and it moves. So it is proved from the experiment. It is proved that passing current can produce magnetic field, right? Or you can say magnetic effect. तो हम लोग क्या सीखा कि हम लोग करंट से मैग्नेट बना सकते हैं. क्लियर सबको? समझ में आया सबको? तो if the scientists thought that if we can create magnetic effect, if we create magnet through current, then obviously we can create current through magnet. अगर हम लोग करंट से मैग्नेट बना सकते हैं, तो मैग्नेट से तो करंट ही बना सकते हैं. समझ नहीं आया? अगर हम लोग करंट से अगर मैग्नेट बना सकते हैं, तो मैग्नेट से तो हम लोग करंट ही बना सकते हैं ना. It was an idea thought by the great scientists. Okay, and this concept was used to invent or discover this generator. Generator, what is there? Magnet. It moves magnet. And magnet is moving tremendously, very speed. So there is a current generated here. Clear or not? So हमको आज आपको हम मैग्नेट से करंट बना के दिखाएंगे. ठीक है ना? So it is clear now, guys? Yes. Okay, very good. So now magnets are of two types actually. Magnets are of two types. Magnets are of two types. One is called permanent magnet. Permanent. One is called temporary magnet. Temporary magnet. Now this black magnet you can see, they are called permanent magnet. They are called because it will have effect everywhere. If you take in the mountain also, it will have effect. Okay, it will have same strength. You cannot increase in strength. You cannot decrease strength also. Okay, it has strength everywhere. Permanent magnet. But here we have another magnet. It is called temporary magnet. As soon as we pass the current, it will behave like a magnet. If we turn off the switch, it will not behave like a magnet. It will lose its magnetic property. The control is now a hand. If you pass current, it will behave as a magnet. If you stop flowing current, there will no magnetic effect. Right? So it is called temporary magnet because the control is in our hand. It is greatly used by the industry to pick up the loha iron bodies, right? In the iron industries, because they need to, like in the iron industry, a lot of things. The plastics are also there, right? They are separate. Iron and things extra and plastic things separate. And they want to melt it. So what they have very big crane, very big coil, and they turn in the switch and they lift all the magnetic things that is related and to the above, and it is going to the main site where they have to melt it, and they will melt this. Clear or not? Yes. Okay. This concept is clear, guys? Yes. Okay, brilliant. Now I will show that how can a magnet or moving magnet can produce current. For this, we need some of the instrument. So here, let me introduce some of the instrument that we are having. Now, how many of you can tell me what is this instrument called? What is this device called? It is called ammeter. You can see A is written, big A is written here. A represents amit. No, ammeter. Okay. Okay. And what is the function of this? What is the function of? What is the meaning of ampere? Ampere is the unit of current. Ampere is the unit of current, and the device name is ammeter. Definitely, it can measure current. So, if it asks what is ammeter, ammeter is a device which can measure the amount of current flowing through the surface. Clear or not? Very nice. Okay, it can measure following things. And here we have V. V means what? Halbasha. Voltmeter. Okay, V means voltmeter. So what can voltmeter do? It measures voltage, or you can say the potential difference of the circuit. Clear now? Next thing we have another G here. G means what? G means what? Girl. Gravity. What a ball. Okay, good. This device is called galvanometer, guys. What is this device called? Galvanometer. Now we have understood the meaning of ammeter, measure current, voltmeter, measure voltage. So what does galvanometer do? Do you know? The main function of galvanometer is to measure or detect the presence of current. करंट है कि नहीं वो समान वो जगह में करंट है कि नहीं करंट का मौजूदगी को मालूम करने के लिए हम लोग वोल्टमीटर को यूज करते हैं करंट है कि नहीं तो आप सोच रहा होगा भाई तो एमीटर और गैल्वेनोमीटर तो सेम काम करता होगा सेम काम करता है थोड़ा सेम है पूरा सेम नहीं है इट कैन मेजर द अमाउंट ऑफ करंट फ्लोइंग थ्रू इट बट इट कैन डिटेक्ट द प्रेजेंस ऑफ करंट it cannot show direction of current but it can show direction of current also कि करंट इस तरफ जा रहा है ना पीछे जा रहा है ओके तो ये काम है इसका काम तो हम लोग किसका हेल्प लेगा अभी करंट है कि नहीं किसका हेल्प लेगा इसका एमीटर या बिकॉज वी वांट टू नो दैट वेदर करंट इज देयर और नॉट सो वी विल बी टेकिंग द हेल्प ऑफ अ galvanometer so what I did I have connected the galvanometer with a solenoid अभी समझते हैं कि सोलेनोइड क्या है भाई सोलेनोइड कुछ नहीं है व्हाट इज दिस वायर कॉल्ड
Bar wire.
क्या कर रहा है ये देखो ना कैसे बोला क्या है सो व्हाट इज दिस आई विल से यू नाउ हाउ दिस मेड हियर वी हैव व्हाट इज दिस insulated copper wire what is this very good hold it now what when the current pass through it what will be there around it there is a magnetic field around it right there is magnetic field around it okay हम सीखा था ना with the use of right and thumb rule we can find the direction of the magnetic field the current is moving from here to here so if you put the finger or the hand like that so you can see the magnetic field now with this straight wire I will make one loop what is this called loop or one circle you can say loop now come here hold it nicely so it is a loop now if I say you how the current is moving in the circle right okay when the current is moving then how will be the magnetic field here what will be the direction of the magnetic field तो मैग्नेटिक फील्ड का डायरेक्शन होगा कि वो ऐसे घुस रहे हैं ऐसे निकल रहे हैं ओके अंडरस्टूड और नॉट दिस विल बी द डायरेक्शन ऑफ द मैग्नेटिक फील्ड when it was straight the magnetic field was ऐसे घुस रहे हैं ऐसे निकल रहे हैं घुस रहे हैं समझ में नहीं आ रहे हैं but when it become loop hold it now so now the magnetic field like that ऐसे घूम रहे हैं ऐसे निकल रहे हैं it is a condition of one loop but if I make many turn if I give many turn now one loop two loop three loop four loop ऐसे करते हैं 1 2 3 4 5 6 ऐसे करते बहुत सारा लूप दे दिया मल्टीपल लूप now I took out now what is this it is called solenoid this is nothing it is number of turn if you get many number of circular turn it is called solenoid means solenoid is nothing it is a multiple of loop clear or not so what is this it's just a multiple of loop many loops are there same way this is also created यही है just difference यही है कि यहाँ पे फूंकता नहीं है कि there is no hole inside it so I cannot use it for creating current so I have taken this one it is a handmade it is a company made there is a hole inside it so that I can move the magnet inside it okay clear or not What is solenoid clear? Yes. Sorry. Now look here, guys. So we have taken a solenoid, we have taken a galvanometer, and we have taken a bar magnet. The strength is not so much. It's very weak magnet. It's a very weak magnet. Okay. If you take the use of a powerful magnet, definitely you can produce more amount of current. But we have a very weak magnet. Then also I will be trying to show the presence of current. Can you see any movement in the needle? No. Why there is no movement? There is no current. Obviously, there is no current, no movement. Now I will take this compass and try to put inside it. Pause.